Okay, yesterday we had learned how to do the understanding what standard deviation is. So let's do a quick review. Standard deviation tells you what? Okay, good. The average distance that the data is away from the mean. The average distance that the data is away from the mean. Okay, so that's what we want to remember about that. Okay, so yesterday we had done this page 8 and we got over to page 9 and we had come up on page 9. We worked through the formula and we got on page 9 that our standard deviation for these vehicles was 2.88. So let me tell you what that means. On average, on average, on average, our vehicles are about 2.88 miles per gallon away from the average of 19.6 miles per gallon. Okay, so that's the average distance that the other vehicles are away from 19.6. Now, we want to see what happens when we had an outlier come into the mix. Yesterday, when we looked at the front, we looked to see what happens when we have an outlier. And we found that the outlier affected which measure? Mean or median? What got affected by outlier? The mean was affected. See, the mean changed when there was an outlier. But look at the median. It did not change. The median was resistant to outliers. So now let's take a look at how an outlier affects this standard deviation of 2.88. So we're going to figure out the standard deviation all over again with an added vehicle that got 44 miles per gallon. Look at these ones up here. These ones are getting 16, 22, 23, 18, and 19. And now we're going to add a 44 into the mix. Does 44 seem to match with the other vehicles? No, it's an outlier. Okay, so we're going to see how that outlier affects standard deviation. Let's go, and I'm going to teach you now how to do this in your calculator. We painstakingly did it by hand yesterday, but I'm going to let us learn the calculator way. Here we go. So go to your calculator, and in the list, I want you to put these, stat edit, and into list 1. So do stat edit, and into list 1, put the 5 vehicles from yesterday plus the outlier, the 44. Okay? So from yesterday, we're putting the 5 vehicles plus the outlier of 44. All right, so now we're going to, what have we always been doing to calculate data in our calculator? 1, variable stats. Good. We're going to do that same thing. So stat over to calc, 1 variable stats. Okay? All right, so on this, let me see here. If that'll come over here. Ha-ha, yay. Okay, so when you take a look at this is the screen. This X bar is the mean. So look at that mean. Did the mean change? Yes. What did that upper outlier do to the average? It used to be 19.6 and it made it go up. So the average is now higher because of that 44 miles per gallon. Good. This number right here, S with the little x, 10.29 is what it would round to. That is the standard deviation of our sample. So S with the little x is the standard deviation of our sample. Yesterday, do you recall what the standard deviation was that we found? 2.88. On average, they were 2.88. They were close to the average. Now, what did that one outlier do to the standard deviation? It's now 10.89 or 29. So what's the difference? What did the outlier do to the standard deviation? It increased it. The outlier was way out there, and it made that average distance bigger. Okay, I want to demonstrate this for you real quick. I want you to think of this picture. If I have data nicely clustered around the center, okay, And then I say, okay, what's the average distance around the center? Okay, those things aren't too spread apart. But what happens if I put an outlier in? What can you tell me about this piece of data way far away? Yeah, it's a big distance away from the center. So that increases that average distance away from the mean. So this outlier made the average distance away much bigger. All right? So in summary, outliers affect mean and outliers affect the standard deviation. Okay, good. I don't have a place. No, you do not have to write all that down because I showed you how to do that in your calculator. In fact, I want you to go ahead and do the next two problems, numbers 5 and 6, and you can do them with your calculator. In the past, I've had students do them do them by hand, okay? But go ahead and do. Oh, you guys, you know what? Since you have a lot of room on this section right here, right? We calculated that the new standard deviation was 10.29. Here it was 2.88. So what happened to what did it do to the standard deviation? The outlier increased the standard deviation. Okay? And in parentheses, the mean also increased. Okay. All right. But you're going to be doing number 5 and 6 right now with your calculator. Just write down what the x bar is and what the s of x is. Just get yourself some practice there. Oh. Okay, good. All right. So we're going to move on to the next item for today, and that is how to draw a histogram and a cumulative frequency histogram. So remember, we previously displayed our data with a box and whisker plot. So now we're going to learn a new way to display them, and that's a histogram or a cumulative frequency histogram. Okay? So basically, let's kind of talk about those real quickly, and then we'll practice them. So a histogram is whenever you make those bars that go straight up and down, and the higher the bar, the high bars have to do with having more items in that bar. Okay? The frequencies, so how tall they are has to do with how many items are in that bar. All right? Now, the bars need to be the same width. That means the width of the bins needs to be the same. You cannot have one that's 2 pieces of data wide and then another one, that's 5 numbers wide. The bars touch. There are no gaps. Okay, so here we go. So there's an example on that. And we'll talk about cumulative frequency next. But let's go ahead and draw some histograms. So turn to the next page, page 11. So I actually have found the assignment on page 12 after I used to just do this page 11. And I found this page 12, and I like it better for the instruction because it has this chart and everything, and it has the nice grid, so it makes it easy to display. So we're actually going to do page 12 and then for the notes, and then I'll have you go back and do page 11 in class, all right? So let's go to page 12 for the notes. Here we go. Peter and Chris Griffin go to a hot dog eating contest. The following data shows how many hot dogs each person ate in 1 hour. So this is some various times that they went to the contest, okay? So there are our numbers. So we want to construct a histogram, and we want to display that. So remember when we made stem and leaf plots, we had to figure out how wide we want our bins to be. Okay, remember we had to figure out how wide we wanted our bins to be. So let's figure that out for this problem. We want to take our max. What's the biggest number we got? Okay, it looks like 90. And what's the smallest number we got? I'm seeing a 44 there. Okay. So how much is that? Is that 46? Okay. All right. Do you recall how many bins I said that we want? How many bins do we want? 5 to 10. Good. 5 to 10 bins. So I'm going to do this. If the less data you have, see, since I only have a few, I don't have a ton of numbers, you probably want more closer to 5 bins. If you have a whole lot of numbers, then you can go to maybe 10 bins, okay? But here, since I don't have a ton of numbers, I'm going to go more like to 5 bins. So if I divide this by 5 bins, in your mind, and I don't need to do this exactly. I want to make this kind of a nice, easy number. What do you think this is going to be kind of close to? Okay, 9 or 10? We can go by 9, sure. But would it be okay to go by 10? I'd pretty much rather go by 10. So I'm going to choose to make my bins go by 10 because I want to go by a nice even number. 10s, 15s, maybe go up by 2s. Okay, maybe go up by 5s. All right? Okay, so I'm going to come down here and we're going to make our bins. So our lowest bin needs to start at what number? 40. Good. And we want it to go, what would it go up to? No, it's 10 wide. So it's going to go up to 50. Will it actually equal 50? That answer is no. So it's 40 up to, but not including 50. So 40 up to 50. And this one includes the 50. So the 50 would fall in the next bin. And it goes up to 60. So I put the little less than because not quite 60. And so on. 60 up to 70. 70 up to 80. 80 up to 90. 90 up to 100. Sure. So let's now put these things where they need to go. 83 goes in which bin? Okay, so I'm tallying it. So I'm drawing a tally mark right there for that bin. 76 goes in this bin. 90 goes in this bin, and so on. I'm putting a tally mark in the bin that they go in. You can kind of do that, yeah. Okay, does that look right? 1, 4, 5, 2, 2, 1. Are those is that the correct tallies that you got? 5, 2. Is that good? All right. Okay. So let's come over here and put our histogram together. So first of all, we need to label what these are. These are, what do these numbers represent? What does the number 90 represent? What's the context? Good. Good. Number of hot dogs eaten in an hour. Okay. Number of hot dogs eaten per hour. Okay. Labeling is important. Okay. Now, I don't want to start at 0. I want to start at 40, so I'm going to make me some railroad tracks so I can start at 40. So how many bins do I have? Like 1, 2, 3, 4, 5, 6. Okay. I think I'm going to go by this, 2s here. Okay. All right. On the left-hand side, we label it number of, hours. So we're going to see how many times, this is the frequency. And you can put frequency here also. So how many times did they eat between 40 and 50? Oh, I need to number these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, so how many times did they eat between 40 and 50? Once. So this is my little bar, and it's going to just be 1 tall. Between 50 and up to 60? 4. So it's going to be a bar that is 4 tall. And then the next one is 5 tall. The next one is 2 and 2 and 1. The 90 goes into the 90 to 100 bar. It doesn't go in the 80 to 90 bar. The 90 has to go in that bin. You could, since they would be whole number of hot dogs, you could label it 60 to 69, 70 to 79. Yeah, you could do that. Okay. All right, so that's our histogram. Okay, next we're going to construct a cumulative frequency histogram. We don't use these a whole lot, but these are going to kind of precede and make another thing that we do easy to understand. So that's why we're going to practice these. These cumulative frequency histograms will be a running total of the frequencies. We will still have the same widths of the bins. The bars still touch each other, but they sum up all of the preceding intervals. If you have a cumulative exam, what does that cover? Everything up to that point. So that's what our cumulative frequency chart will look like. So you'll have this, and by the time so I have this, and I add more data for a total of this much. And I add more data for a total of this much. I add some more data for a total of this much. So by the time I'm here, I have all of the data in here. I have accumulated it all. Okay, so let's practice that on our example here. Okay, it's the same situation, so we're going to use the same bins. So let's do our little 40 to 50 and so on. Okay. So there were our frequencies. I just took those numbers from the one above. 1, 4, 5, 2, 2, 1. Okay. Now I want to accumulate the numbers. So in order to accumulate the numbers, I start adding up. So this one starts at 1. The next blank is 1 plus the ones I added to it for a total of 5. Now 5 plus the next bar is 10. 10 plus the next section is 12. See, I'm adding that next section to it. 12 plus the next section makes 14. 14 plus the next section makes 15. So we'll end up with a bar that is 15 high. That will be our final bar. So let's come over here and start our same thing the same way. Number of hot dogs per hour. Because you do not start at 0, so I do railroad tracks to start. Okay, so this on this side is not just frequency, but it has to be labeled cumulative frequency or it is wrong. If you do not put cumulative on here and you do what we're about to do, that would make it wrong. Cumulative, the word cumulative is important if you're drawing a cumulative frequency. Yeah, I'm going to add one over the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Up, let's go up one little more to 15. Okay, so my first bar, so these are the numbers that I'm graphing. The cumulative frequency bars are the ones that I'm graphing. The 1, the 5, and so on. Okay. So we don't use this a ton, but there is another graph we're going to learn at a later time that understanding how this works will help you. Okay? All right. So there by the end I have my 15 times all stacked in there. Okay? So I could say, how many times do they eat less than 70? How many times do they eat at most, you know, 69 or less? How many times do they eat 69 or less hot dogs? 10. Good. How many times do they eat, less than 90 hot dogs? 14. Okay? All right. Nice. Now go back to our previous page, this one, and you're going to do these yourself. So look at that, how there's no grid. So sorry about that. What I did to do mine was I kind of drew a little in half, and I made my little marks here, and I kind of figured out what I want my bins to go by. And you might want to make yourself some lines. I've got rulers I can share with you. Yep. So you might choose to make yourself some lines so that since you don't have a grid, okay? And then over here, you're going to make the cumulative one. So this one will be the cumulative frequency, and this one will be the regular frequency. And I'll get you guys some things. So you're going to want to first figure out the bin size, and I will walk around and help you guys.